Hi, in this video, I'm going to show you how to develop and use the unit circle. The unit circle is a device for helping us remember angles and values to the angles, special angles, but we use those the most, 30, 60, 45, 225, those kind of angles, and how to kind of find them real quickly. So what we're going to do is I've drawn a big circle here. And you can pause this video at any time. And what I'm going to do, this is your x-axis, and this is your y-axis. And then through this, I'm going to construct. Now on this particular circle, this radius from here to here is 1 unit. That's why we call it a unit circle, because we're going to use the unit of 1. These angles right here, cutting through, we can see this is a 45-degree angle right here. And we're going to draw another one right through here. Okay. And then we're going to draw some 30 degrees. 30 goes through here and here. Pretty accurate. And a 60-degree angle. See, from here to here would be 30 degrees. From here to here, I should say. Well, I can actually draw it in. This is theta. This would be 30 degrees. This is 45 degrees. So, and if I went way up here, from here to here would be 60 degrees. Okay, and I could draw that right through the center. And we do the same thing down here. So we get this is what we call a unit circle. And it's just a device to help us kind of convert angles to radians and radians to degrees and all that good stuff. So you should have something drawn that looks sort of like that. Not the best. Now I'm going to cheat. I actually have one drawn. Right? So, put mine down here. Okay, here's mine. Okay, so let's start out with this positive and negative thing and what the heck they're talking about here. Remember in the first quadrant, all students take calculus. Okay. I'm just going to list the positive angles. All students that would positive would be sine and cosine. And not sine and cosecant. Sorry. And here it would be tangent, T for tangent, and cotangent. And down here, it would be calculus, would be cosine and secant. All students take calculus. Now I'm going to show you how to fill this in. I'm going to start from the basics and then we can see. This is 0 degrees, right? This angle here, we can tell is 45. 45 plus 45 is 90. This is a 90, so I'm adding 45 each time. 40 plus 90 is 135. And you can use your calculator if you need to. 35 and 45 is 180, half a circle. 180 plus 45 is 225. 225 plus 45 is 270. 270 plus 45 is 315. Got those filled in. Okay, now we're going to add by 30s. This angle right here is 30 degrees. 30 plus 30 is 60. 60 plus 30 is 90. 90 plus 30 is 120. 120 plus 30 is 150. 150 plus 30 is 180. 180 plus 30, 210. 210 plus 30, 240. 240 plus 30, 270. 270 plus 30, 300. 300 plus 30, 360, 330. 330 plus 30 is 360. So 0 and 360 are the same. And now we have all the angles filled in. We had to do the 45s first, then do your 30, 60, 120, 150, and so on. Going around, you're adding 30 each time. Okay, now we're going to convert those to radians. Well, how do you convert an angle to radian? Okay, well, you can take the angle 30 times pi over 6, pi over 180, excuse me, I'm getting ahead of myself. And that would give you pi over 6. We could do that for each one, but that's kind of time consuming. So let's see if we can figure out a way to do this. That would be a little bit easier. So maybe we could start with the 45s. 45 is, well, let's see what it is. 45 times pi over 180. 4 times 45 goes into 4. So it's 4 pi over 4. So this is pi over 4. Let's list it over here. 2 pi over 4. So we're adding pi over 4 each time. 2 pi over 4, reduce it down to 1/2. So this is pi over 2. So 90 degrees, pi over 2, same thing. This was pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Well, 4 over 4 is 1, so this would be just pi. 5 pi over 4, 6 pi over 4. Let's see, 6 can be 6/4 is 3/2. 6 pi over 4, 7 pi over 4. And we've got them filled in. So 315 and 7 pi over 4, same exact thing. Of course, this would be 8 pi over 4. 8 over 4 is 2 pi. This would be just 0. So 2 pi and 0 radians is the same thing. Okay, now let's do the 30s. Let's see if there's a way we can do those. Well, we know this one was pi over 6, right? So now this would be 2 pi over 6. Could write it or could reduce it, pi over 3. 3 pi over 6. See, 3 over 6, 1/2. Okay, 4 pi over 6. Well, it's 4 6s. Just jotting it down, that would be 2/3, 2 pi over 3. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 4/3. 4 pi over 3. 9 pi over 6, reduce it. 10 pi over 6. 10 over 6, 5/3. And 11 pi over 6. And of course, 12 pi over 6, 12 pi over 6, 2 pi. So all we're doing is reducing those fractions. We went by 6s. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and so on. Now we're going to fill in the values. What is the value of 30? So let's look at the main ones here. The distance here we said was 1 unit. So this is 1. And this point right here, we don't go up at all. So that's the 0.10. What's the name of this point? This point is 0. And we went up 1 unit, 1. Okay. What is this value? This would be -1, 0, right? That'd be right. And then this would be 0, -1. So we got those filled in. What's the big deal about filling those in? Well, let me show you a little trick. This value right here is always the cosine. The first value in this parentheses is the value of the cosine. And the second one is the value of the sine. It's always cosine, sine. So the cosine of 0 degrees is 1. The sine of 0 degrees is 0. Let's do this one. Again, cosine, sine. The cosine of 90 degrees is 0. The cosine of sine of 90 degrees is 1. In every one of these parentheses, this is the cosine and the sine. Cosine, sine. Cosine, sine. So if you wanted the cosine, or say you wanted a sine of 270 real quick, it's -1. The sine of 270 is -1. Well, let's see if we can fill in the other ones. And I'll show you a little trick. The bottom numbers on all these going around is going to be 2. This is going to be a 2. This is going to be a 2. You can just fill them all in. They're always 2s. 2s. These are going to be 2s. 2s, 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 2s. So now we know the bottom numbers. They're always 2. How about the top numbers? 0. We're going to go with square roots. We're going to start with it going around this way. And we're going to start with this one, just to help us out to get started. Square root of 0 is 0. The square root of 1 is 1. The square root of 2, the square root of 3. Square root of 0, square root of 1, square root of 2, square root of 3. Let's go this way. Okay, this is the first one. So this is going to kind of square root of 0, square root of 1, square root of 2, square root of 3. But in this quadrant, the cosine is negative. So we want to make those negative. Okay, 0. But now what we're going to do, we went around like this. Okay, now we're going to start with this one right here. We're going to put it right down here. Square root of 3, square root of 2, square root of 1, which is 1. Square root of 1, we're going to go over here. Square root of 2, square root of 3. So it goes 3, 2, 1, 1, 2, 3, 3, 2, 1, 1, 2, 3. See, there's a pattern. And that's what's exciting about this. There's this pattern going on. And then remember, in this quadrant, the cosine is negative. So we got to make those negative. This stands for the cosine. So if I wanted to find the cosine of 210 degrees, it's the same thing as pi over 6. It's negative radical 3 over 2. I can find it real fast. Okay, now these are just the opposite. 1 and radical 3, 3 over 2 always go together. So this is square root of 1, square root of 2, square root of 3. Going around, square root of 3, square root of 2, square root of 1, 1. Going around, 1, square root of 2, square root of 3. Going around, square root of 3, square root of 2, square root of 1. In the first quadrant, the sign is positive. In the second quadrant, it's positive. But in the third quadrant, it's negative. And in the fourth quadrant, it's negative. So this is your sign. If I want to find, so now I filled it in. I've got all the information I need. Pretty cool. Except one other thing I like to do is I like to find a tangent of each one of these. So I'm going to put the tangent on the outside. And we know that the tangent is equal to the sine divided by the cosine. Okay? Tangent equals sine divided by cosine. So let me put this over here. I'm touching my keyboard is what I'm doing. Okay. So the sine is, let's take this first one. The sine is 1/2. Remember, it's the back number. And the cosine is radical 3/2. And you're going, oh my God, look at that. It's okay. Both these numbers are the same. And we could rationalize it, but I'm not going to. It's 1 over radical 3. 1 over the square root of 3. Okay. Here I have radical 2 over 2 and radical 2 over 2. 2's cancel out. Radical 2 over radical 2 would be just a fancy name for 1. Okay, here I have, let me get a new sheet of paper here. Here I have radical 3 over 2, the sine, over the cosine, 1 over 2. 2's cancel. Got radical 3 over 1, or radical 3. What do you think is going to happen? We're going to go around the circle again, aren't we? We're going to do just like we did before in the last one. This is going to be radical 3, 1, 1 over radical 3. 1 over radical 3, 1, radical 3. Radical 3, 1, 1 over radical 3. And now you've got your tangents right away, so you can find your tangent, because that's usually what we use, sine, cosine, or tangent. So all the tangents are going to be outside the parentheses. Now, let's fill these in. We know the tangents are positive. Tangents are going to be negative in the second quadrant. In the third quadrant, the tangent is positive. All students take calculus. And then in the fourth quadrant, they're negative again. Okay, so we got our signs in. Well, you're saying, what about these? Okay, well, it's sine over cosine. 0 over 1 would be 0. Over here, you got 1 divided by 0. Can you divide 1 by 0? No. So it's infinity. Over here, it's going to be 0 divided by negative 1. That'll give me a 0. And then over here, it's going to be negative 1 divided by 0. So that's going to be infinity. So I even know the tangent of 270 is going to be infinity or undefined, either way. So now I've got all my things. All I got to do is look at it. So if I want to find some problems, let's grab some out of the book here real quick. This is what, 2.3, I think this is. I'm hoping it is. Okay, it's not. 3.2, huh? 3.2. 3.3, I'm sorry. 3.3, okay. It says, what is the sine of pi over 2? First exercise. Sine of pi over 2, here's pi over 2, 1. Real easy. What is the sine of 7 pi over 6? So I got to look at my drawing here and see if I can find the 7 pi over 6. Here we go. 7 pi over 6, the sine. Which one is the sine? cosine, sine, negative 1/2. Bingo, I've got it. What's the cosine of 5 pi over 3? Cosine of 5 pi over 3. Where would 5 pi over 3 be? Right here. What's the cosine? 1/2. Cosine, sine. So it's a real nifty little trick to find all the missing things. One last thing. Sometimes they want you to use your calculator. I can't even find one here. Take this one out. This one kind of doesn't work so great, but go to that. But I want to find it in radians. So you want to make sure, if you want to find it in radians, then you're going to go up here, hit your degrees, and slide over to radians. Okay, normally we want answers, but sometimes they want them in radians. So then I want to find the sine of, I want to find sine 0.6109. So what I want to do on this is I want to hit 0.6 sine, and now I converted it to radians, 0.6109, parentheses, and then of course hit equal. And let's see if we come out with the right answer. That'd be 0.5736. Probably carrying about 4 decimals. So I can find the sine, but make sure when you're done, I would suggest you go back and change it to degrees, because most of the time that's what we work in. But make sure you haven't changed the radians when you're doing these exercises. It says calculate the approximate value for the circular function. They're talking about in radians. Okay, it didn't really say that. So you want to be kind of careful about the directions. And I think most of these are pretty self-explanatory, that you won't have too much trouble. It says find the exact value of S. Okay. They gave you this pi over 2 and pi. Let's see what they're talking about. This is number 61. They have something written like this. Well, we know that's 90 degrees, and this is pi. So, and they want the value of sine S equals 1/2. So let's see what they're talking about here. Not quite sure what they want. Let's see what they're talking about. It says find the exact value of the circular function. Do not use a calculator. Pi over 2 would be 90, and pi would be 180. So maybe they're saying that the angle is between these two, and then it's 1/2. So if it's 1/2, it's going to be 5 pi over 6, because we want the sine. Sine is either it's going to be, I guess if they want, the sine of S would be 1/2. Would be 5 pi over 6, or it would be 150 degrees. I don't know what they wanted it. Let's check. I'm going to check my answer, and they wanted 5 pi over 6. So this is your boundaries right here. It's between pi over 2 and pi, which is between 0 and 90. And then I wanted the sine function, which is 1/2. So we're converting it over 5 pi over 6. So it's a pretty fantastic little way of finding your values without doing a lot of extra work. I can see on my timer, I don't know if you can see the timer, but I'm running out of time. So I hope you enjoyed this thing. You might have to draw one yourself, or you might see a little quiz coming up. All right. So let's see what we can do on this. Whoa.